Mr. Romeri
Yes.
is the first one. Do you agree with this order or not? Because
no problem. If someone prefer to be the first, I can wait. It's up to you.
Okay, Mr. Romeri, then Mr. Clerici, and last but not least, Spital, okay?
Very well.
Okay, let's start with this session. Good morning, everyone. Welcome to this session. I'm your chair. My name is Emanuele Piccino. But first of all, I have to specify that at any time I want, my talk isn't on behalf of ENI, of course, it's a personal view. We are talking about hydrogen. Is a very important, a very good topic because everywhere and a lot of people are talking about energy these days. I don't know where and which is the end point of these talks, but I'm sure that we are ready to have a good debate about this, starting for our first speaker, Mr. Romeri. Mr. Romeri is an energy consultant. His presentation is about hydrogen and fuel cells, back to 20 years of professional experience looking forward beyond COVID-19. Mr. Romero, if you want, the floor is yours. I mute my microphone and you have 20 minutes, up to 20 minutes.
Thank you very much, Mr. Chair, for your introduction. I'm very glad to give this presentation in University Bocconi because I am a Bocconiano, and I start quickly because there is a lot of things that I can tell, but time is running. I give an outline of my presentation, why I decided to, looking back to my 20 years of professional experience. Because when I was writing the abstract, I noted that 20 years ago, I made my first short note about hydrogen and fuel cell, but I'll describe later. Then I give only an outline. And after I think and try to find any answer to the fact that in these 20 years, there are three main waves of interest for hydrogen and fuel cell, but the first two waves failed. And I tried to find the motive, the reasons why. And after I move to my core idea that in the last 10 years I present all around the world. So that idea is to consider the opportunity to consider an hydrogen fuel cell powertrain as a power generation plant. Then I give some conclusion about this overview. Trend, please. I start my professional activities in RAS insurance in 1988 as financial analyst. And then I move inside the group in 1996 to Raspin to be a senior equity analyst specialized on Italian energy and industrial sector. As I mentioned before, in July 2000, I wrote my first published short comment on hydrogen oxygen fuel cell titled Settore auto recenti sviluppi in fuel cell, that described and comment the July 19 press release of Nuvera Fuel Cell, that in this date, Nuvera shipped first gasoline-powered fuel processor system to auto manufacturers worldwide. This is an onboard reformer, is a solution that forgotten. And I was surprised from this fact. Then move away. In my subsequently 5 years of Raspin activities, I was responsible for analysis and research and advisory unit focused on new and renewable energy, in particular fuel cell and hydrogen energy vector. In this period, I was appointed as expert in the 6th European Framework Program of Energy. I attended to the first EPHE meeting in Washington. Then I cooperate with the Hydrogen Coordination Group that in 2005 published the first AIEE book on hydrogen, a prospect for hydrogen fuel cell. Then I attend to many meetings to the EU Hydrogen and Fuel Cell Technology Platform, to the Carbon Sequestration Leadership Forum. And as I said before with Alessandro, I attended to the WEC 19 Congress in Sydney, where I made a presentation and I wrote a paper. I was a component of the Piattaforma Nazionale Idrogeno Acciaio Combustibile that was built in 2005. And then I cooperate with the Zero Regio project, an FP6 project based on Mantova and Frankfurt am Main. Then in 2006, I attended to the Hydrogen and Fuel Cell Technology Platform, where the main industry involved in hydrogen activities made the first declaration of an appointment of 5 billion in the next 10 years. In 2007, I moved back from the Allianz Group because in February 2007, Allianz Group announced a broad integration project of the Italian RAS activities. In this context, RASFIN analysis unit stopped its activities. And in front of the possibility to readdress my activity to a more traditional role in the field of financial analysis and advisor, I decided to begin an independent consultant activities. In September, thanks to my initiative, and the collaboration of Region Lombardia and the Fiat Group and the Conference of Italian Bishop CEI, it was possible to organize the involvement of two Panda hydrogen fuel cell vehicle to the Holy Father Benedict XVI when he held the pastoral visit to Loreto at the Agora of the Youth Italian, and meet around 500,000 Italian young people. In September was published the Climate Change, Mitigation of Climate Change, the fourth assessment report of IPCC, where I have the pleasure and the honor to be mentioned with my paper and presentation that I made in Sydney. And this publication, the fourth assessment report, give the opportunity to the IPCC to be honored with the Nobel Peace Prize. Moving away, I wrote many papers, but the first were interesting because I was talking about the US Energy Policy Act that define the paradigm from 2005 to 2020 about the fuel cell and hydrogen in US. And in 2009, I wrote a prophetic text. Hydrogen fuel cell is a possible post-Kyoto instrument, and in this day, we are talking about that. But let me move quickly. I attend to World Bank, Clean Energy Missile One. I be appointed other 2 ways from the EU as expert, but move to more stringent aspect. My focus, my analysis fundamentally is the idea that fuel cell powertrain can be useful to as a propulsor of a car, truck, bus, and so on, but is in its substantial structure a small, not so small, power plant. So I decide and I start to compare the hydrogen fuel cell powertrain levelized cost of generating electricity, LCOE, based on the US public data with traditional power generation technology. with very promising results. I made presentation in China, USA, Japan, Italy, and Korea in this year. And in the last 4 years, I focus this kind of solution with the more concrete reality. In 2015, I was in Los Angeles, and I asked a question. But hydrogen fuel cell is a Cinderella or a disruptive low carbon solution? From my point of view, is a disruptive low carbon solution, but at that time, it was a Cinderella. Then in 2018, I talked about the connection in between hydrogen fuel cell in the Paris Agreement 1.5 degree perspective. And finally, last year, I argue about the possibility that hydrogen fuel cell could repeat his history, because hydrogen fuel cell was the technical solution that gave the opportunity to the men to go to the moon. And at the end of this overview, I was to the main question. In 2009, I underlined that in the last 15 years, it was a tremendous technological progress in all the field, and also in the field of hydrogen fuel cell. But it has several waves of interest, one of which fully translated into rising sustainable investment. And at the end of this overview, I found 3 main waves. The first around the year 2000, the second in the year 2006, 2008, and finally the present waves, in my point of view, started in 2007 to 2008. At this point, I try to describe my personal point of view about the failure of the first 2 wave and the lesson learned from this experience useful for the present moment of strong interest for hydrogen fuel cell. First of all, it is necessary to clarify that my analysis in the first 2 waves is focused on transport and transport sector, with the focus on light-duty vehicles or the mass production vehicle. And the most important question is why these 2 waves are not able to fully translate in a rise in sustainable investment. In my opinion, the answer is not only in aspect directly related to this new low carbon solution, but also to it is strongly linked to other external major events. Let me explain. In the first wave, around 2000, year 2000, if I read an UNDP comment, major automobile companies are planning to have a commercial availability of fuel cell vehicle by 2004. They are currently demonstrating prototype to improve them. Several automakers have set the goal to introduce fuel cell into the automotive market during 2008-2010. And 4 years ago, 4 years later, UNDP made another assessment overview in which this paradigm changed completely. The market entry target moved from 2003, 2010, 2010, 2015. What is the problem? Excessive expectation, from my point of view, a too short time frame. But there is also 2 major events in this period. External events, the dot-com bubbles and subsequent financial market collapse. When I talk about Nuvera, the project about Nuvera was to be quoted, to be listed in the US stock market. But with the financial market collapse, this project failed. And also, there is another tragical moment, September 11, 2001, with the tragedy of New York and all the US. Let me spend rapidly the focus of many interesting initiatives launched, policy initiatives launched in this period. In the US, the National Energy Policy, then the Hydrogen Energy Roadmap, the President Hydrogen Fuel Initiative, and then the US Energy Policy Act that we'll talk about, and the Energy Policy Plan. In Europe, the starting of fuel cell technology platform, but the interest moved also to international platform, the G8 at Gleneagle Plan of Action. And in this period, the Kyoto Protocol came into the force. The second wave is, from a point of view, in 2006, 2008. In this time, in this period, we have a new time frame scenario, 2020, defined by the US Energy Policy Act, that fixed only two goals. Is a federal law that fixed 100,000 hydrogen fuel cell vehicles in the US by 2010 and 2.5 million vehicles by 2020. All these new targets failed. And it was a law with all the Department of United States involved to achieve this goal. But what's happened? First of all, there is a global financial crisis in 2007-2008. Then a great major economic recession from 2006 and 2013. And this recession gave a tremendous impact on the US automotive sector. Think about 2009 when the administration forced Chrysler and GM to a structured bankrupt process. So for this reason, obviously, certain target fixed not many years before was lost. And also changed the perspective from the hydrogen production that move from natural gas or methanol or ethanol or gasoline to coal, to water, and to nuclear. So in this way, we lost the focus that, in my opinion, is fundamental in these initiatives. Let me move to the third wave. In my point of view, this wave started in 2017 when Hydrogen Council presented the report Hydrogen Scaling Up. Then was increased with the Hydrogen Energy Ministerial meeting in Japan in 2018 and the G20 in 2019. Then was published an AIEE and report in 2018 and AIEA, the future of hydrogen in 2008 that refocused the interest in this Cinderella solution. But from my point of view, the most important things is a new political will. This new political will was really evident in the period of COVID-19 pandemic. And the EU Commission proposal, the EU European Climate Law, Hydrogen Strategy for Climate Neutral Europe in July, and all the money connected with the multi-annual framework and the Next Generation EU. Attention, because in 2020, many European and other countries published or updated their national hydrogen strategy. Netherlands, Portugal, Germany, France, Spain, USA, and Italy in November. Italy is under
Excuse me, Valentino, you have 3 minutes.
3 minutes? Okay. Two things. The time frame scenario can change from 2030 to 2015. And the attention move from light duty vehicle to heavy duty vehicle. And the attention obviously moved to green hydrogen. But we have the COVID pandemic, the financial and market crisis. But from my point of view, the most important concern today is about a possible future and subsequent economic recession, because we saw what happened in US in 2008, 2009. okay, I don't talk about the Paris Agreement, and I move to my focus. In a past study, I focused my attention to the fact that fuel cell powertrain is a power generation plant, and the cost to produce fuel cell electricity from a fuel cell powertrain is competitive with the other costs. In this paper, I use, in this presentation, I use the data from a precedent study, because there is an extreme volatility. Also, you think that the oil give a negative price during the pandemic. So I prefer to use this kind of data. But there is a fundamental fact. I not comment this kind of data because you can read with attention, and you can find all the movement of the price and of the cost during the years. But from my point of view, the most important things is that in 2018, we talk about a mass production of 500,000 fuel cell vehicles per year. In 2009, when we talk about mass production vehicle, we talk about 100 fuel cell vehicles per year. But let me move the second again. Next. In this slide, it's possible to note that when we talk about heavy-duty vehicle, we talk about 1,000 vehicles per year. And when we look the number, we found that the present cost of fuel cell for heavy-duty vehicle cost around $119 per kilowatt.
Excuse me, Valentino, I don't want to interrupt you, but time is a bit over.
Okay, but the lifetime is very long, and this made comparable with the previous large-scale production. So this changed completely, because at this kind of production, this solution is competitive now. At this point, I stopped, and then if there is some minutes later, I conclude my observation. Thank you.
Okay, thank you, Valentino. Maybe during the Q&A session, we have a Q&A session at the end of all presentations. So as agreed, now I will leave the floor to Alessandro Clerici.
What have I to do?
Oh, we have to...
You just need to share your screen.
Yes, you
like
have to
we
share
had
screen
before.
And present your...
Yes, what have I to do? Do you connect my presentation?
No, you can do it by yourself.
What have I to do? Share the screen?
Yes, share the screen.
Okay.
Okay.
It's okay.
Okay, and now you have to go
to the full screen.
1, 2, 3, 4. Okay. Perfect.
Oh, now I have to take out your faces because I don't see the presentation. What to do here?
No, do you see your presentation or not?
Yes, I see, but is practically covered by your faces, so I don't know how to eliminate the faces.
Maybe you have.
I have eliminated.
Okay, perfect. So you can start, Alessandro.
Yes, one moment. Okay. Oh, now they are horizontal. They are taking away a bit. Okay. Okay, so I start.
Okay.
Good morning, friend.
You have 20 minutes. I remember you. Another, please.
Yes. In any case, I've seen there are only 2 people attending, so we can complete in the discussion something I don't finish in the presentation.
Okay.
So let us start with, the title is Hydrogen Era. Yes, but when and at what cost of delivered energy? Clearly, a green hydrogen is a very fascinating element to contribute to the energy transition. I have to eliminate. Hydrogen economy is now in a different situation than in the past due to the development of RES that can be seen in two roles. An active part in power to gas as energy suppliers to produce green hydrogen, or an interested party in hydrogen gas to power for long-term storage and auxiliary service for a better integration of RES in the electrical systems to compensate their variability. Let us look some general data on primary energy resources worldwide and the position of hydrogen. Just the global primary energy consumption has been this value, just world 1.6 average annual growth in the last 10 years. Non-OECD 60%, always increasing. OECD 40%, zero average annual growth with respect to 3 of the non-OECD. EU, you see, minus 0.8, and Italy minus 1.5. The contribution of hydrogen to the consumption of primary energy, 2.1% in the world, 1.8 in EU, 1.2 in Italy. If we look to primary energy consumptions for different sources, as you see in the world, oil is dominant, and RES, non-hydro, are 5%. Total of wind and solar is 3%. Non-OECD, dominant coal. OECD, dominant oil. Europe, dominant oil. Italy, dominant gas, and a portion of oil. If we look to the global emission, this value, just we have 2/3 are coming from non-OECD with an average annual growth of 2.5, with OECD minus 0.8, Europe minus 1.8%, and Italy minus 2.8%. The contribution of the production of hydrogen to the emission of CO2 is 3% in the world, 3% in EU, and 1.5% in Italy. Just you see from here how it's increasing the difference between non-OECD and OECD. Just in 2030, European Union will have around 6% of global CO2 emission. The Green Deal will have little effect on the global solution. An EU-centric vision is not enough for a global solution. Energy, a privilege for someone or a right for all. Let us think of sub-Saharan region with 1 billion people, 120 per capita consumption with respect to EU, and in some countries 1/10 of this value, 600 million without electricity. India, considered a major emitter of CO2, 1.3 billion people, they emit about 1/5 per capita of CO2. Now, global primary resources with the proven resources and actual production, we have 50 years for oil, 55 for gas, 155 for coal. Proven resources for oil and gas are now 50% larger than 20 years ago, even with a substantial consumption in the last 2 decades. Real problem is not lack of fossil fuel, but mainly how to burn them without impact on the environment. The new explosion of interest on hydrogen. During the full day on hydrogen at the World Energy Congress of September in Abu Dhabi, I was there. A great discussion with the main interested stakeholders for that. July 20, as Valentino has mentioned, the European Commission hydrogen strategy. And there is an increase in talks on green hydrogen in all the world. You see every day in the newspapers. To move from feasibility analysis and to, I don't see the screen, big devil, and to go to application of hydrogen with safe and economically sustainable production, compression, storage, transport, and use, there are still open great challenges. A considerable media resonance on the future of green hydrogen, with a lot of data on power of electrolyzer, reduction of cost per kilo, job created. very few numbers on the characteristic of hydrogen and on the cost, not per kilo of H2, but on the hydrogenery cost for the end user. I will concentrate my presentation on green H2 production cost, with some comments on challenges to use existing methane transport infrastructures. Why is not moving? I don't know what happens. Are not moving the, hello? Hello?
We can hear you, Alessandro.
Hello?
Perfect.
No, it's not moving, are not moving anymore the slides. What happened?
There's some.
You just need to press the button, no? It's not working.
No, just
Try
if you
again.
What to do. I don't know what to do. It's all blocked.
Just wait.
Okay. What's happened? Hey, your presentation it stopped. Okay.
What happened? There is a problem of connection. I don't know.
Yeah, is your connection?
I have connected through Wi-Fi. What have I to do?
Ok, allora, la presentazione è fatta dal suo PC ed è il suo PC che ha problemi di connessione.
Come problemi di connessione? Non li ho mai avuti.
Quindi può uscire e rientrare
Come
sulla
faccio?
slide. Scusi, in alto a destra non ha una chiusura una X per chiudere?
No, maybe
stop share. Stop share.
Try.
Stop share.
The share. Yeah.
Fare la presentazione.
Non ho capito.
In basso c'è scritto share o condividere lo schermo.
No, in basso non si riesce ad aprire niente, è tutto preso dalla presentazione.
Ok, allora può premere ESC sulla tastiera.
Cosa premo sulla tastiera?
ESC.
In alto.
ESC, in alto a sinistra.
ESC, sì. Ok.
Ok,
adesso
perfetto.
Riparti.
Allora, ripartiamo, preme la presentazione normale, vada avanti con la slide prima di tutto, vada alla slide 13. La 13, quella dopo, perfetto. Può riaprire la presentazione.
Vedete?
Sì.
E allora la tengo in piccolo così?
Ok, se preferisce
la vedete lo stesso in piccolo?
Can you see, John Max?
Yes.
Okay,
yes, okay.
Thank you.
So I go on in this way to avoid problems.
Yeah, this is better.
Now, let us see. I will concentrate my presentation on green hydrogen production cost with some comments on challenges to use existing methane transport infrastructures. The colors of hydrogen, yesterday from a friend that came out another color, pink hydrogen from NGA. Now, there is no an agreed declaration. According to the talks I had in Abu Dhabi, I will consider black hydrogen from fossil fuels without any capture of CO2 emission is 99% of the current production. Gray hydrogen produced with partial sequestration of CO2 emissions. Blue hydrogen from non-renewable energies, but without CO2 emission. Example, fossil fuels with total CO2 capture, or electrolysis from nuclear electricity. And this is the cheapest way of producing blue hydrogen and also hydrogen. Green hydrogen produced entirely from renewable energies. The characteristic of hydrogen. Hydrogen is found in water and in organic compound, is not present free in the earth, and is produced with processes that require energy. It is an energy vector. The energy per volume unit, both in the gaseous and liquid state, is about 1/3 of that of methane. In weight is 2.5 times that of methane. Remember this number, 1 kilo of hydrogen has a content of energy equivalent of 33.2 kilowatt-hour if you use that with an efficiency of 100% clearly. Which is the future scenarios for global consumption in 2050. Great difference from different sources. IRENA in Abu Dhabi said 8,060 terawatt-hour. Just in Bloomberg, 27,000. Hydrogen Council, 21,900. And if you look also the share for the use in industry, transport, buildings, power generation is quite different. For instance, Hydrogen Council consider a certain portion for power generation, here is not considered. What are the present production of, what is the present production of hydrogen in the world? 110 million tons, according to AIEA, and compared to 50 in 1990, something less than 3% average growth per year. There are also numbers 20, 35% lower. Just what about Europe? Just according to some analysis, what happens? Let me see, I don't understand what that. Let's go there, because I don't see the screen. Just Hydrogen Europe foresee for a very ambitious program to have 23% or 24% of hydrogen as relevant to the consumption of energy in Europe. EC, something less. Let us come to Italy. Just the House Ambrosetti study commissioned by SNAM are saying 218 terawatt-hour for various uses, plus 100 terawatt-hour for electricity production. It means 23 plus 10, 33% of the primary consumption of Italy in 2050. The Italian RSE is just considering something in the range of 8%. Now, I have attended a very interesting World Energy Council section from the WEC of Germany. They have analyzed 56 countries around the world, just with 9 already having the a defined strategy for hydrogen and 3 under development. Just if you look at the main results, the majority of countries is for main goals involved in support national technology development and reduce emissions. With respect to the hydrogen uses, the main one was considered from the country's transport, the second industry, the third power, the fourth buildings, and one group of nations, 5, they want to develop hydrogen mainly for export: Spain, United Emirates, Russia, Australia, and Morocco. You know Morocco has an agreement with Germany for export to Germany of hydrogen. Now, production cost in 2019 and 2030. Now 99% of hydrogen is produced in black way. With the steam methane reforming, we have 9 kilos of CO2 for 1 kilo of H2. The production cost of black hydrogen for the 2019-2024 period in the range $1.25, $2.5. It means 32.64 euro megawatt hour. I would like to remember that the pool price in Europe for gas is now 13, or before the COVID, now is less. According to local gas, this is depending from local gas costs, and neglecting or not CO2 penalty or CCS. With CCS in 2018, AIEA was saying the cost is $1.5, $2.7 a kilo. Look at green hydrogen at the exit of Electrozyler, was evaluated by Hydrogen Europe at the Abu Dhabi section in 7.8 kilo to 235 euro per megawatt hour, with reference to onshore wind in northern Germany, 2,000 hours of load factors. I jump these slides, we can discuss how it was composed later. Just the price of hydrogen will be mainly connected to the cost of the renewables and their load factor hours, taking care the expected great reduction of cost of electrolyzer and the increased efficiency. How to feed the electrolyzer with RES that should have an interesting load factor for the economy of the produced green H2. Electrolyzer placed at the RES plant does not pay transport and system charges, having a combination of electricity price and relevant load factor interesting. Power supply, the second way, through a dedicated line from RES, don't pay transport system charges, pays the interconnector investment, and the rules are different in different countries. Power supply from a substation of the transmission grids, pays transport and system charges. In Germany are some tens of euro megawatt hour already today, excluding incentive to RES. And this is resulting in our cost of energy at the electrolyzer, and therefore higher cost of H2, even if partially compensated by an increased load factor to be defined. Around 2030, Hydrogen Europe predicts in Germany a cost of green hydrogen from offshore wind with 4,500 hours per year, the double of Italy, at around €3 kilo, 90 euro megawatt hour. I jump now, what Siemens was saying is in agreement with that. 2050 scenario. IRENA assume at global level a cost in 2050 of $200 kilowatt of large electrolyzers, now is 1,000, of several hundred megawatt. RES cost $20 megawatt hour, load factor or 4,200 hours. In this hypothesis, the green hydrogen at the electrolyzer exit would cost $1.4 kilo, equal to 1.2, which correspond to 36 euro megawatt hour, about 3 times the present cost in the pool price in Italy for gas, clearly without a penalty for CO2 that should be considered. Just with respect to synthetic methane, downstream of a power to gas for hydrogen production, it has been proposed a subsequent transformation of hydrogen into gas, into electricity, or the production of hydrogen combined with CO2 for a synthetic methane that could use all the structure, power plants, machinery and equipment and user facility developed and in operation since decades. But the price of the energy content of the synthetic methane, according to the Horizon 20 Store and Go project, would be between 50 and 120 euro per megawatt hour in Europe. Some comments of green hydrogen in Italy. Both the green hydrogen cost at 90 euro megawatt hour at the electrolyzer and the synthetic methane of 150 megawatt hour based on a green hydrogen 3 euro kilo are levels that require challenging efforts with difficulty to be reached by 2030, considering our load factor of wind 2,150 according to PNIEC, and maximum in Sicily 1,500 for solar. The cost of 1 kilo of green hydrogen at the electrolyzer located at the wind plant would now exceed 7 euro kilo, and by 2030, close to 5.5 euro kilo.
Excuse me, Alessandro, you have 3 minutes.
Sorry?
3 minutes, please.
Okay. I'm sorry that I've lost time. If we consider...
No, I haven't considered it.
Okay. If we divide by 2 the cost of electrolyzer and electricity, we would reach 3 euro a kilo in 2050. With gas to power from H2, it will be the cost 5 times the present production of combined cycle plants, and by far higher than the direct production from RES. If we want to decarbonize Italy by 2030, we should have to add or 12 gigawatt of wind or 18 gigawatt of solar. H2 in existing pipeline, Snam has done nice things, but if you put hydrogen with 1/3 of PCI, we will reduce of 7% the calorific value of the entire mixture. And we have to consider all this implementation to do in the infrastructures. Now, if we look at methane use in existing pipelines, so one is saying 100% hydrogen, it will transport lose 2/3 of the present energy capacity. European community, you have, 40 gigawatt electrolyzer to produce 10 million tons of green hydrogen by 2030, but some doubts, 40 gigawatt with an efficiency of 75% expected in 2050, and with a factor of 5,000 hours per year, above the present one, will give less than 1/2 of that. For 333 terawatt hour, you would need 89 gigawatt of electrolyzers, having an efficiency 75% at 5,000 hours. If you connect to the network, you need 8,300 hours of load factor. And you would have not in 2030, 100% from renewable. So we will not have green hydrogen, but a mixture of green, gray, and also black. Conclusions, I take only one that seems interesting. For Italy, it is a very difficult challenge to approach now and perhaps in the future, the values for production cost per kilo of green hydrogen, as in some countries favored with local condition, and we can give. Should be interesting to investigate small, new effective electrolyzer, containerized up to 1 megawatt to serve local H2 demand and fed by near-rest plants. And we have already in Italy one factory. What could be of interest is that in about a decade, with important MEC from rest plants amortized at the end of feed-in tariff, it will be working to check the situation of the real rest prices offered per kilowatt hour in Italy. It should be only operation and maintenance. Just, I would say also that it will be necessary to compare with the results of parallel studies and actions for blue hydrogen, for the spread of H2 in the most convenient way for the country, especially to facilitate an initial phase of CO2-free H2 diffusion. The current amount of H consumption, industrial uses, current cost of green hydrogen production, the already difficult task need to and always increases use of electricity from RES in its own market require the use of all technology at our disposal, and that could be a bridge for future solutions that are not yet mature in Italy. Just given the challenge and still open, it is necessary to proceed with caution in proposing now too optimistic times and low energy cost, especially for green hydrogen, and this could be a boomerang. And just effective communication is the last one, must be implemented to involve and raise awareness of all citizens to be willing to spend more for green energy in order to create a possible better future for world environment. Great work for everyone in this phase of transition, and for the possible development of H2, they still require strict analysis and experimentation with power to gas and gas to power, with an approach not only technological, but also socio-economical, and effective team working of all the technology for real long-lasting impact is essential from Aspera ad Astra. Many thanks for listening.
Thank you, Alessandro. Many thanks for your presentation. Now it's time for Jean-Marc Schwital. It's a PhD candidate from University of Padua. Is it correct, are you?
That's correct, yes.
He's talking about one of the main conclusions, so the ancillary service market or the emerging market for power to gas. It could be a great point for hydrogen, and especially to integrate renewable sources in the energy market. So I'll leave you the floor. You have 20 minutes, please.
Right, thank you very much, Mr. Piccino. Well, as my personal experience, professional experience is way shorter than the one of the two preceding speakers, I will focus more on numbers that we produced because I don't have so much others to share. But I hope this will be satisfying as well. So I said, I am a PhD student at the University of Padova. My background is engineering. I'm an energy engineer. After that, I did an MBA at a business school called Collège des Ingénieurs. And now I'm doing a PhD to combine the two worlds of economics and engineering together with Professor Arturo Lorenzoni from Padova. My talk today is about the opening of ancillary service markets and how that can emerge power to gas opportunities, specifically in Italy. So to start with, as some background, I'm not sure how familiar you're with this. In 2017, in Italy, Terna, the TSO from the electricity side, started a big project, the so-called UVA project, which for the first time allowed, on the one hand, the aggregation of small units, and then subsequently also the participation of these formerly two small units in the Italian ancillary service market. What they did as of now with this was hourly balancing services for the electricity grid or tertiary reserve. And it started with units of consumption that were aggregated. Then they had units of production being aggregated. And eventually, in 2018, the two streams were mixed. And now we have the so-called mixed units, which can be aggregates of be it both production or consumption units as one virtual unit, which then can participate at the market. And the new thing about this is really, on the one hand, first of all, the aggregation, but still also the size. So even being aggregated, the minimum size of the aggregate is only 1 megawatt. Before that, the minimum size for a plant as a whole to participate in the market was 10 megawatt. So you can see that already that was a big jump besides the aggregation. And overall, this project intends to assign 1 gigawatt of distributed flexibility participating in the market of all units which were previously not enabled to participate in the market. So that was a huge step forward. And indeed, the project is now running since more than a year. The target of 1 gigawatt of new flexibility resources assigned to the market has been reached. They are in the market. They're not as active yet in the market as one would like, maybe. There's several reasons for that, but the key point is they are in the market. So units being smaller than that nowadays can participate. This is the main point from here. And to participate in the project, you are even eligible, if you want to, for fixed payment, which is up to 30,000 euros per megawatt per year through downward auctions. And then you can participate in the normal market of ancillary services in Italy for the product of hourly balancing, so for tertiary reserve. This is a bit the background of our work, why we started this work, because we saw that the ancillary service market in Italy opened, and we asked ourselves, what does this mean? What does it imply? And which business opportunities emerge from this? So what we do, why we do this is that we saw in this also opportunities for power to gas. And there's a lot of interest now rising in power to gas. Everybody is kind of agreeing on the fact that power to gas capacity is wanted to balance the inherent volatility from renewable energy sources, or also for security of supply over the entire year in moments when there is no sun or no wind so strong. So everybody wants it, but the question is, how can we get it? And does it need therefore specific incentives, subsidies, or not? And everybody also kind of agrees that it should be, as far as possible, market approach. And so the question is, if it is a market approach, what are the business opportunities as of now through that? And what might be the missing gap to be still filled? So the research that we found so far, which was looking at the actual market integration, often did not look from a power to gas operator's point of view, but rather from a systemic point of view. And they usually used average prices of an entire day, of an entire year even, and usually also look only at the energy-only market, so taking wholesale market prices. The new thing about us is now that we say, if you have a plant, that one should not only work constantly. It should not only work on energy markets, it should work on all markets available, and that implies also ancillary service markets. So we used therefore this UVAM framework, where we simulated the participation of the power to gas unit on the Italian market with real market data. Italy, fortunately, is in the situation that it has a public market operator which publishes all market data. So we used hourly data from the electricity markets, hourly data also from the ancillary service markets. And then based on these numbers, we ran the simulation of a power to gas plant participating through the UVAM project. We analyzed two output scenarios. On the one hand, a mere power to gas electrolyzer producing hydrogen, and then also subsequently with a methanation unit. And we applied that for all market zones of Italy, because as you know, Italy has 6 market zones, now even 7 with Calabria just as a last zone. And results change depending on which region you are actually. Just some of the characteristics of the plan of the study that we ran. I don't want to go through all of them. You can see them afterwards in the slides. But we ran the simulation for a plant of 5 megawatt size. All characteristic data here comes from real plants being installed in Germany, one in Hamburg and one in Mainz, which are one of the 2 most industrialized plants constructed as of now, through which data has been published. So it's a 5 megawatt plant that we use with different efficiencies. The average one at rated power is 54% as modeled. We have the investment cost capex of 10 million euros, OPEX cost of 4% per year from the capex, and so on. This is all just the background data for our simulation. Now, what we actually did then, or we tried to do, is to show these business opportunities of such a plant as it has now in Italy, and to compare, therefore, the classic operation on energy-only markets, as it is often discussed in literature, versus the active participation also through balancing markets. And well, I said, we used data from 1 year. We used the 2019 market data for the day-ahead electricity market and for the balancing market as ancillary services. And for the gas side, of course, there is no hydrogen market as of now. So there is no market price that would vary. For hydrogen, we assume the fixed sales price of 3 euros per kilogram, which matched also with what my 2 speakers before just mentioned. It is kind of the target price for 2050. And we assume that this would be already the price at which the plant would have to sell nowadays, if it would produce hydrogen, to see how competitive it is already now, to be competitive also with other hydrogen sources from gray hydrogen or blue hydrogen. And for this synthetic natural gas, we use the market data from the natural gas market, assuming that in this case, the plant would feed in the synthetic natural gas in the natural gas grid, and then therefore sell on the respective day-ahead market. The major assumptions that we had, and of course we had to take some. First one was that the plant procures electricity at market price. So it does not pay any taxes, levies, or others. This is for 2 reasons, or in 2 scenarios would be reasonable. One, as just mentioned before, that the plant would be directly attached to, say, a renewable energy plant, behind the meter, if you want, with a wind farm or solar farm. Or also in the other context, since there is no real regulation yet for power to gas plants in Italy, but supposing it would have a similar regulation as, for example, large-scale storages batteries have, because also for battery, these levies and taxes do not apply, since they're not seen as a final consumer who would have to pay these taxes and levies, of course, but just as a unit to grid stabilization or a transformation of energy from one vector into the other. Therefore, they are exempt from these levies, and we assume that the same would happen also for power to gas. But it's of course an assumption because there's no such regulation as of now. We then assume in the simulation, if we do the realistic cases, that the plant would have no knowledge of upcoming prices, would only know past prices from last year's or last days. So it doesn't know the future. And you know that the balancing or ancillary service market in Italy is not the same as the wholesale market. From its clearing mechanism is not merit order and you get the maximum price, but you get pay as bid what you have been bidding. So of course, there's a lot of thinking about the strategy of bidding and to kind of have a criteria that we had to choose. We choose a deliberately conservative criteria that we said only if the bidding that our plan did would have been better than the weighted average price of actually accepted market offers, we think that it could have been accepted in that zone. Of course, in theory, there's no guarantee for that. In theory, even with a price just at the marginal price, it still could have been accepted. But we choose a deliberately conservative because we saw in the database that actually is not always the best price, which is directly being accepted, because Terna has also other reasonings for accepting beyond the pure price. Anyways, this is the background. Now, looking at the results, the first thing that we did was to compute different results for different zones. And I want to show you some background data first on to market zones. On the left-hand side here, you see results from the zone of North, while on the right-hand side, you see results from the market zone Center-South. This is the balancing market results from 2019, the entire year, plotted along the x-axis. The bars, which actually don't look like bars, but rather like stripes, are the accepted quantity in this market, not from our plant, but overall in the market, accepted quantity. In blue being the downward quantity, and in red being the upward quantity. And then the individual dots are the respective prices of these offers being accepted. And what you can see clearly here is that if you look on the left-hand side on the market zone of North, there's a lot of quantity being accepted for downward. There's quite some, but significantly less quantity being accepted for upward balancing services. And the price levels are somewhat constant. So the price level for downward is somewhat around 30 to maximum 70 euros, even less, 50 usually, euros per megawatt hours, while the upward price is somewhere between 70 to maximum 120. And then there's some outliers, but that is the major range. That is the quite stable and big zone of North. If you look on the smaller, much smaller zone, Center-South, on the one hand, you see, first of all, that the quantity is way less compared to North. I mean, there's a lot of hours where there's nearly no quantity being accepted because there's no quantity needed by the TSO, by Terna in that moment. And on the other hand, the price is much more scattered. You still see some patterns. There is kind of an imaginary line or around 500 euros for upward balancing. Beyond that, nothing is accepted, or also not bid if you want. But there is a clear line around that. And then there's still the lower limit, which is somewhere around 70 to 100 euros, also for upward. This being said, it looks quite scattered, all this data first, but what we did then to kind of make it more clear is to plot the cumulative distribution functions, which is taking the entire year and plotting it as within one day. And you can see on the left-hand side, again, the results for the North, and the right-hand side, the results for Center-South. And we distinguished here, of course, the plots for upward and downward balancing. So the very left, this one here, is the price for upward in the North. And you can see that the curve is somewhat constant. There's no big distinction over the range of the hours. So no matter what hour, the probability to be accepted at a certain price is more or less constant. Same then also for down price. In the zone of Center-South, on contrary, we do see an hourly pattern. And we do see, for example, that the prices diverge for the early morning hours, or even the night hours if you want, on the one hand for the for the downward balancing, but even so also for the upward price. So there is a clear hourly pattern in this market zone. I think this is a key major takeaway from market background. Now, jumping into the results from our plant. The first thing that we did was to analyze that the plant would be operative only on the electricity market. So buying electricity on the national wholesale market and producing, in this case, hydrogen or synthetic natural gas from it. The plant acts thereby as a price taker. And we also calculated the marginal price without repaying CapEx and OpEx, but just selling hydrogen at €3. So if I want to recover my costs, like the €3 per kilogram, if I want to reach that target, what can be my electricity input price? And if I only have as revenue stream the hydrogen, that means that the electricity price, marginal electricity price, is €48 per megawatt hour. If it is above that, I'm not able to reach the €3. If it is beyond that, I do have some economic margin to operate. If I sell not only the hydrogen, but as a byproduct, I also produce oxygen. And if I could sell that, because it is actually a product which could be sold and which has a value, then my marginal price rises slightly. So I can also operate up to €61 per megawatt hours. This is for the electrolyzer part. If I then have subsequently synthetic natural gas plant, you can see how this price drops strongly. It is an indicative marginal price because there is no fixed selling price. If you would take the average annual gas price of the natural gas day-ahead market and take that as our output price, the resulting marginal price for electricity is €3 per megawatt hour, €3.4 per megawatt hour electricity. So that is very, very low. And even if I would sell then still my oxygen, and I also have heat from the methanization, which could be sold as industrial heat to other processes or to district heating or whatsoever, even if I incorporate these, my marginal price is 19.7 euros per megawatt hour. So that is very, very low. The two reasons for that, already to say, is on the one hand, the gas price, natural gas price, is very low. So that makes these input prices also comparatively low. And on the other hand, you need CO2 in the process. And the CO2 has a price, of course. It doesn't come for free. And the price that we took was 60 euros per megawatt hours, which came from an industry process. And that was comparably high. That is also bringing down this margin price. Anyways, as a result, you can see if this plant...
Yes, you have 3 minutes. 3 minutes.
If you see that, operative hours, of course, are 3,000 up to 7,000 hours. And you have a positive net cash flow if you only produce hydrogen, but you don't even get a positive cash flow with synthetic natural gas. Now, positive net cash flow sounds good, but already if you subtract the annual operation costs, this gets strongly negative. Slightly remains only if you would sell oxygen. But again, this is only with operation costs, since you still haven't paid the capital expenditures, the investment costs, and you haven't made any profit. So just to give one idea, if you use this case of sale of oxygen, your payback time of the plant is still 129 years, and you still have a net present value of minus 9 million euros. So still there is no business case if you only use the day-ahead electricity market in Italy, even being accepted from taxes, levies, and so on. Now, you could do the same. We took this for PUN. You can do the same if you don't pay the PUN, but the zonal prices, there's a big discussion if the plant should pay zonal prices or PUN. You can see the distinction here for different zones, but I don't want to go into that. Rather into balancing markets. Now, if you use balancing market and you want to provide upward services as here, that means you offer your entire capacity of 5 megawatt for upward balancing, meaning I procure 5 megawatt on the day-ahead electricity market, and then I can offer that my plant shuts down, because reducing consumption is the same as generation rising up. So by reducing my consumption, I offer upward balancing to the system. And this is what we simulated here. If you would be an omniscient player, so you perfectly know the prices for today and for tomorrow, these are the results. you can see that you can generate quite some cash flow here, just with operation additionally on the balancing market. The highest cash flow comes from North, around 1 million euros per year, or a bit more, 1.1 million euros per year in the North, but the other zones then are comparatively lower again, because simply the market doesn't accept so many hours. So there's no need for so much balancing in other zones. This is the results for the ideal case. If you then would not know tomorrow's price, but you have some kind of bidding price based on past prices. In our scenario that we ran with the bidding strategies that we implemented as of now, of course, these numbers seem like an illusion, and you drop down to still quite low cash flows. But it shows how much more cash flow you can generate just by operating also on the balancing. Now, if you want to do the same with downward balancing, not only upward, but downward, what do you have to do? If you want to offer downward balancing, you need to run with the plant at lower level. So baseline is 1 megawatt. And then you can offer to increase consumption up to your nominal of 5 megawatt to kind of then offer downward balancing to the grid. Because if you increase consumption, it's the same as the generator decreasing its output. So the numbers are here. Operating hours for that are pretty good, especially for the North, but the cash flow is much lower simply because the prices are not so interesting from a power to gas unit as for upward balancing. Okay, to discuss what we found, electricity prices as of now are not sufficiently low to make power to gas a business case if you only work on energy markets, even if you're exempted from taxes and levies. There is something if you also sell additional revenue streams, such as oxygen or potentially green certificates. And the key takeaway here is that balancing markets actually offer an interesting upgrade to be more cost competitive. It does matter there which location you are, which market zone of Italy you are. And it is more challenging because acceptance is not guaranteed. And we also found a paradox that it is more interesting for a power to gas plant to offer upward balancing, meaning being shut down, being paid for standing still, than offering actually downward services. And just to conclude, the very last thing, this UVAM framework as of now, which is by Terna, opens up new market opportunities. And it is a win-win situation because on the one hand, it supports grid stability, electricity grid stability by integration from new decentralized flexibility. And at the same time, it opens up new business opportunities or additional revenue streams for market agents. What we would like to do now is to combine our model with specific distributed energy resources. For example, with the load curve, the generation curve of an actual wind plant. We want to go more into value stacking. We saw already what you can do with energy market arbitrage, what you can do with tertiary reserve. And just now, Terna also opened the secondary reserve for UVAM participants, and that one's even better remunerated. So there's even more value stacking possible. And also here, we're talking only about the market products. We're not talking about financial products, which could still offer additional value streams. And advanced bidding strategies. My point for discussion now to you is, where do you see interesting points for this future application? Where would you would like to have more insights on? Is that rather internal plant aspects, such as, for example, the bidding strategies, or how much a technical increase in efficiency could bring? Or would you rather focus on external aspects, changing market design parameters, applying it to data from a different market, or to something completely different? Thank you very much for your attention. References are attached here, and now I'm looking forward to the discussion.
Hey, thank you, Jean-Marc. I haven't seen any question from the audience, so let's start maybe with one of mine. I assume that we are quite far from a market, but we have significant targets for 2030, especially for hydrogen. In your opinion, which are the best solutions, or which could be the solution to address these targets without having some maybe issue with competitivity of price in terms of prices of energy. Maybe we can start from Valentino, that you were the first.
Honestly, I was thinking about my presentation, and I would like to underline one point. Why I made all this kind of analysis. Because in my perspective, in my point of view, we are in front of a movement in which the price of electricity components like electrolyzer or electricity power plant like fuel cells are moving in a way so quick that we have never seen before. I talk about electrolyzer because I attended to an online conference 2 weeks ago, and Bloomberg NEF present a data about the cost of electrolyzer alkaline in China. That is 1/10, un decimo, 1/10 of 5 years ago, and is 80% less than the present Western electrolyzer made. So when we talk about track and fuel cell track, I try to describe that we move in my study from many years. I use always the US DOE data from 500,000 vehicles produced and sold per year to 100 to 100,000 to 1,000. And in the last 3 years in China, the bus and truck fleet moved from 150 bus in 2018 to 4,000 bus and truck in 2009 and 60,200 in March 2020. So I can describe that 1,000 of EV duty vehicle product per year is a number that it's now realized in some parts of the world. But we are not so familiar with this number. So when we talk about the equilibrium price, the service price, and so on, and so on, and so on, it's okay. But what could happen in between 2 years if China continue to move in this way? So, I have no answer. I can only underline the fact.
Thank you. Thank you. And Jean-Marc, what do you think about it?
Well, to be honest, it's a very challenging question because as of now, the push for new technologies in the energy sector has often been accompanied by quite high costs, which we also see now for renewables. So to avoid that the same story repeats with hydrogen, I think is challenging. But what I found encouraging is that actually now numbers are picking up by themselves already without even having incentive schemes or subsidy schemes in place. So I think it is quite important to see that maybe we as academics, or at least I can only say that from my side, I lagged behind for quite some time the actual reality, in the sense that now electricity prices are already so low, which have been incredibly unthinkable some years ago. I think now the last auction for PV in Portugal was just 1.5 cents, so it was incredibly low for generation costs. And on the other hand, also the technology of electrolyzers seems to go on, and it doesn't necessarily directly compete with our everyday natural gas, which we use for homes or for other industrial uses. But it does compete for specific values for industries. And in Spain, there has just been the case of Iberdrola signing a big agreement with a fertilizer company for 20 megawatt electrolyzer in July. That was a project for 20 megawatt of electrolyzer with PV and everything, which was used because the company wants to produce green fertilizer. And that has been so promising that they even changed it now up to 800 megawatt over 7 years of electrolyzer. So that is a massive amount, and which is not because actually it would be that the market price competes with natural gas, but because it is about the value for the company and the low input prices from electricity, which they can use. So I think we're already in a good street. What I'm missing, to answer your question, what I see most challenging is more, as of now at least, the regulatory framework. Who is allowed to run these plants? Because there's a big interest also from system operators, DSOs and TSOs, or SNAM as the gas side TSO. Are they allowed, or is it only a private entity that may run it? And what are the conditions? Like, are they really exempt from taxes, levies, or which ones apply, which grid tariffs, and so on? This needs to be cleared because as of now, it is often not. But yeah, that is would be my answer.
Thank you. Alessandro, if you want to answer, but first
Yes.
of all, I just received a question. In your opinion, it's a question for all, but you can start. In your opinion, which is the most likely leading country for the future of hydrogen? In which country will have an advantage and which one will be disadvantaged? I know that, Alessandro, you can have an answer.
So, Italy will have a clear disadvantage because we have very low load factor for wind with respect to the North Sea, and very low load factor, suppose, with respect to the Emirates, and costs. Just the $13.5 per megawatt hour offered in Abu Dhabi, and I was there at the signature of the deal, are not comparable with what would be our cost for two main things. One, the insolation is 2,600 hours with respect 1,500 in Sicily. Second, cost. The cost of panel is a small portion now for photovoltaic. In Abu Dhabi, they have cost of labor for installation and operation and maintenance, $300 per month. The Pakistan, the Indians, and so on, with respect to our 3,000s. The cost of land is zero, given by the government. The cost of money is zero, given by the money. So at least we will have 2.5 times the cost per megawatt hour for that. And if I believe in Europe, the two countries that will be advantageous, or four perhaps, just one. If we want to develop, in my opinion, quickly in Europe, a market for hydrogen, we have to start from blue hydrogen. Because now you can produce in France. I was speaking with my friends of EDF the other day. The marginal cost of nuclear in France, or the total cost of already amortized plant, is less than 30 euro per megawatt hour with 8,200 hours per year. So you arrive at the cost of CO2-free hydrogen at the beginning that is very low and could be a step for introducing hydrogen in the market. So I see France, Germany, Portugal, and Spain are in advantage with respect to Italy. And this is my feeling, at least. And in any case, the big problem I see for hydrogen is connected to the compression, transport, storage, and distribution. And because you have a lot to do on that. Blending, I have not shown in details the slides, but you have to consider in details what you are having to do for the pipes, for the weldings, for the measurements, for the compression, and so on. Another thing I would like to ask Jean-Marc, what for gas to power with hydrogen, which kind of components have you considered? Fuel cells or gas turbines?
Well, to be honest, we didn't even look at that part, gas to power. We only went the other way around, power to gas, and then selling the gas, either in the grid, in the gas grid, as synthetic natural gas, or as pure hydrogen, which is sold to end consumers, be it industrial users or be it also vehicles that then use them in fuel cell, of course, at this fixed price. So unfortunately, as of now,
for balancing, you have not considered gas to power of hydrogen?
No, it is the flexibility of the electrolyzer itself, that the electrolyzer itself can ramp up or ramp down. So consume more or consume less. It's pure the demand side management, if you want.
So you consider the electrolyzer only as a load to the network and the supplier of gas. Because exactly. A big problem, do you know, is that Terna is having in the Italian system, and not only, I was in Germany, they are thinking to transform the alternators of the nuclear plant they are dismantling in big synchronous condenser to give inertia to the system.
Yeah.
Because do you know that all photovoltaic and wind are connected through inverters that are not contributed to the short circuit power and to inertia. Just to give you a figure, if you have a fault in Naples, 10 years ago, you have a circle of 100 kilometers with a voltage drop more than 10% that can be disruptive for the loads connected to the factory. Now it arrives up to Rome. If we don't take care of that, it arrives in 2030 up to Vienna. Do you know Terna is installing 20 synchronous condensers of 250 megawatt each with a flywheel just to increase inertia. And what I see other people differently from what you have done, Mark, is considering gas to power from hydrogen or from synthetic methane. But from hydrogen, if you use fuel cells, you don't contribute to the inertia of the system. So you have to invest additional money to counteract for that. So we have to apply a very holistic approach, a system approach to consider all the advantages and disadvantages. But the key issue, in my opinion, for Italy, Italy will not be in a position to be a cheap supplier of hydrogen.
I'm a mechanical engineer, so my knowledge is, of course, somewhat limited. What I know from my colleagues in the university from electrical engineering is that as of now, you're completely right that especially the existing plants of photovoltaic, also wind, do not provide any inertia. But actually the new inverters are capable of providing synthetic inertia. So as soon as either there's a market for that, because as of now in Italy, primary reserve is not remunerated, but that will come. There's now this pilot project Fast Reserve, which has just concluded, I think, like 1 week ago, with, I think, what was it, overall 300 megawatt of new resources, mainly batteries, I guess, which will now provide.
Battery with special inverters with a tremendous power to have in milliseconds a lot of power. I don't say what is the cost because I know that.
Maybe this could be additional costs. Maybe this could be a suggestion for next year, one topic or for next year or two. I don't know when will be the next AIEE Symposium, but maybe we can chat another time about this. That could be also a very important market for the future, I know, but I'm not sure. Maybe Jean-Marc knows better than me.
No, if I may respond very quickly only to the comment of Mr. Clecci, which you made about that Italy is disadvantaged. I would like to contrast that a little bit, because I think Italy, yes, from what he said, you're completely right, has disadvantage. Same as Germany, by the way. I think for generation of hydrogen, you need to have a lot of renewable energy. So space is an issue. Labor costs are definitely also an issue. So I think Germany is at least the same disadvantage on that terms as Italy. But I would see, on the contrary, some advantages for Italy, because Italy is, I would say, at a very strategic position for import of gas into Europe. We all know that even if we go to green hydrogen, we will never be auto-sufficient. We will never produce so much green hydrogen within Europe as we need to satisfy our own needs. So there will always be a strong import. And that can either come from the north, from Norway and others who have maybe a lot of offshore wind, or especially from the south where they have a lot of PV. So I think Italy has a strategic position there. That is a big advantage. And at the same time, Italy is very much experienced with gas in general, also on the consumer side. So I think in Italy, nearly every household is connected to the gas grid. While in Germany, that is definitely not the case. In France, even less. In France, everybody heats with electricity and cooks with electricity. So there's no experience with gas. While in Italy, this is the case. So I think this is something Italy can leverage on, that there is a lot of industry and consumers already experienced with gas and their respective infrastructure being in place. And I don't know in detail how much change it needs to change the infrastructure, but Snam just announced that they would basically have 70% of their gas grid ready for hydrogen, for 100% hydrogen. That was a statement that the head of innovation just did a couple of days ago. I found it surprising because I didn't expect the number to be so high. But well, if that is the case, then Italy has a big advantage because it has a very large gas infrastructure, which apparently doesn't even seem to be so far away from being ready for hydrogen.
Okay, I'm sorry to interrupt you, but I think time is over because it's 20 past 1 o'clock, so we have to
a very quick...
oh, yes, please. Sorry, Valentino.
Two suggestions. The first one is regarding the most advantaged countries. I think China. Why? Because it's too easy to move to greenfield to reorganize energy system. Then second, with my look back experience that I made in my speech, I found two technologies completely forgotten. The steam reformer on board, the steam reformer of gasoline on board, realized, but completely missed in the paradigm of fuel cell. And another solution, the steam methane reforming at the recharging station that ENI made an excellent experience during the Zero Regio project. In this way, it could be an answer to the question of Alessandro, the cost of moving hydrogen and store hydrogen. We produce hydrogen from natural gas at the using point. And in the first phase, we use a green hydrogen, a black hydrogen. We move forward the number of vehicles that are fuel cell vehicles. And then we move to green and other more ambitious solution. But if Italy would play a role, have the opportunity, because Nuvera came from Milano, from Italy. ENI is a main player. It's up to this player to give the role of Italy in this match.
Thank you, Valentino. Thank you to all the speakers. No,
I just want 2 words.
Sorry, but we don't have enough time because we have to be strict in time. Thank you very much, Alessandro. We can call. We can have a chat or call later. See you next time. Who knows for hydrogen? We have a lot of things to do. Goodbye, and thank you.
Hoping to have a better audience and not 3 people, because I will never present a new paper to IEEE.
We hope so. We hope so. Bye.
Thank you very much. See you. Bye-bye.
Ciao to everyone. Have a good day.
Ciao.
Ciao. Ciao.